Question number 8. We are told that the curve C1 has the equation y equals x squared all multiplied by x plus 2. And in part A we are asked to find dy by dx. So let's just expand our function first. So we've got y equals, well, x squared times x is x cubed plus 2x squared. So dy by dx equals 3x squared plus 4x. In part B we are asked to sketch C1 showing the coordinates of the points where C1 meets the x-axis. So just a sketch, so we'll just draw some axes. Now if we look here, if we set this to 0, we know that x equals 0, or x plus 2 equals 0, so we've got x equals minus 2. So we've got something going on here and something going on at minus 2. Now x squared, this is a repeated root, and we have a positive x cubed, so we have this sort of shape, and because x squared is a repeated root here at the origin, the curve just touches at 0, 0. So we can draw this in, comes up through minus 2, comes down, just touches 0, 0, a minimum, and then goes up to infinity. Okay, in part C we are asked to find the gradient of the curve where C1 meets the x-axis. So if we have a look at the graph again, we're looking for the gradient here and the gradient to the curve here. So if we look here first, this is where x equals 0. Now the gradient function is telling us dy by dx equals 3x squared plus 4x, and clearly when x equals 0, dy by dx equals 0. That's if we substitute 0 into these two x terms. Looking when x is minus 2, well, dy by dx, if we substitute x equals minus 2 into this, we get 3 in brackets minus 2 squared plus 4 in brackets minus 2. Well, minus 2 squared is positive 4, 3 4s are 12, minus 8, so the gradient to the curve at x minus 2 is 4. Okay then, in part D we are asked to sketch the curve C2 that has the equation y equals x minus k all squared, x minus k plus 2. Now let's compare this to the original function, and the original function was y equals x squared in brackets x plus 2. So the only difference between these two is that we've got a translation of x minus k, which means the translation is in the positive x direction by k units. Now we are told as well in the question that k is greater than 2. So all we need to do is move the graph 2 units in the x direction. Sorry, k units in the x direction. So So k has to be greater than 2 because that's what he told us in the question. So if we look at the original sketch here, so we know if k is greater than 2, this point needs to go just past the origin, and this point needs to go k units in the positive x direction. So let's sketch this. So we have a point here, we'll call that k, and we have a point here, we can call that k minus 2. And we just sketch the same shape. It comes up, comes down, the minimum just touches and goes up. Now the final bit of this question is asking us to state where the curve touches the x-axis. We've already done that, and we also need to know where it crosses the y-axis. Well, where it crosses the y-axis, we can set x equal to 0, and if we look at the original function here, if we set x equal to 0, we will get minus k squared in brackets minus k plus 2. So minus k squared is positive k squared, and we've got 2 minus k, and that is where the curve crosses the y-axis. So our coordinates are x equals 0, y equals k squared in brackets 2 minus k. And that is the end of question 8.